Hello. Hey there. Hi, I'm Solar Luna. I'm an independent game developer. I'm the creator of this cool PS1-esque, well, very PS1-esque 3D game made with Go and Tetra 3D. But I'm also the creator of MasterPlan, and that's what we'll be working on today. But this is just a little scene that I made in this adventure game, this little like top-down 3D walk around and talk to people adventure game. That you get to actually from oh, for some reason, let me see, there we go. That you actually get to from the convenience store. You go into the convenience store and it's just like a destroyed PS1 JRPG overworld. I don't know, it just feels fun. And so that's what I'm gonna do. I'm gonna make this weird, cool, interesting game. Um, yeah. So anyway, that's what I've been working on. Between last stream and this stream, what I did a little bit was I messed around with Wasm, trying Wasm for scripting instead of using JavaScript. JavaScript is great. It works well. It's just, it's a scripting interpreter. So I was like, well, maybe there's something that would allow me to have more code completion and work with. Oh, that smack came through really loud. Sorry about that. Code completion or auto completion and stuff like that. But Wasm, even if I could get it to work, which I could, but it would revolve around passing bytes back and forth between the host, which would be the game, and the guest, which would be the the script. So, for example, the player script would be a Wasm runtime, or the Wasm runtime would contain the player script and would be executing it. There's a couple problems. One is that it requires compiling your code to a Wasm file, which takes a non negligible amount of time. It's like maybe 5-6 seconds minimum. Maybe 3 seconds minimum, which is kind of long when you're talking about iterating, right? When you're talking about like building code. And then on top of that, with Go, if you build with Wasm, it can't import any code that contains C code. You can't contain any code that uses C, which means that, for example, Tetra 3D wouldn't work in Wasm because it importing the Tetra 3D package makes it impossible to build because there's no Wasm build files for certain code, structures and things like that, or no Wasm platform like defined, which makes sense. But that basically means that I would have to kind of like separate out vectors and matrices and helper stuff like that into their own files, and I'm not sure if I want to do that. So anyway, I mean, this works currently. It works pretty well. The only issue is that there's not really very strong typing because it's JavaScript, and the code completion basically revolves around having a stub file open, so that you can do things like type engine dot, and then you get all the functions like that, right? So I mean, like, it's not necessarily the worst thing in the world. It does work, but it is not ideal. Yeah, it's not ideal. So anyway, hmm. Yeah, it's not ideal. Anyway, but it does work. Um, and I mean, there is upsides to JavaScript. It is dynamic, right? So if I use the dynamism effectively, then that could be an upside. Um, yeah, so I mean, there's definitely upsides, but at the same time, it's not necessarily the easiest. It's not. I don't know. I prefer Go, so it would be nice to write things in Go. But this does work. It does work. So maybe I should just kind of like forget about being specific as to what tool I'm using and just kind of work with this for now. But now what we're gonna do is we are going to work on MasterPlan. That's for another day. MasterPlan is where it's at right now. So last time we left off, we were working with web cards, and they were working really well. The main real issue is that there's no like sharing of web card data. It's spinning up a new browser for each web card, which is not ideal. We really would rather share a browser across all web cards. So that would be cool to do. Someone else also in Discord made a suggestion of embedding all assets into the plan file, which is interesting and is doable. Yeah, it's doable. But it's not going to be necessarily the easiest thing in the world. But then again, there's only two types of media, right? Images and sounds. So it should be possible to do, even though it's not perhaps as easy as it would be, as it, you know, as easy as we would like it to be. It should still be possible. So that's something we can also think about for the near future. For now, let me just take a look at the sound contents. I want to take a look here. Also, I updated my computer. That's probably why this is taking a while. It has to recompile. Let's see. Update. Load file. Okay, so this says this is the sound, right? Yeah, resources.get file path. So we could basically get or make a resource, a variant that basically handles things if it is a byte string as new sound. We open the file path, and then we create a stream, huh? We decode the stream, which is something that implements read closer. So we could use a bytes, like a byte reader, and provide that reader to this function with the byte slice. That would work. Okay, so it is possible to do. Images should be relatively simple. GIFs should be relatively simple. Okay, so that should be something we could do. I think every other resource is not anything that needs to be stored external to the thing, right? Yeah, just textures. So that extension. As image, is GIF, as GIF, is sound, as new sound. Parse. Okay, this is where we start parsing it. But we can detect from a byte slice. So maybe we should detect from the byte slice and open the file and read it. That way we can provide a byte slice or provide a file and then just read the file. Yeah. So then we are looking through, getting the splitting it to an image. Okay, so that's fine. Download percentage. Okay. So this should be doable. So we'll see about that. I think I added a to-do for that. Yeah, this is it. That should be relatively easy to do. So I'm going to kick that up to the top of the list. after web cards. So this is working. The issue mainly now is that these two do not share any resources whatsoever. These are two instances of Chrome running on my computer, and we don't want that. We want to basically have these both be tabs. But the reason why I'm doing it this way is because browsers aren't made to run multiple. Well, maybe I need to do it this way because basically browsers aren't made to run multiple tabs visible at the same time. When one tab is visible, the other one becomes invisible and is throttled and stuff like that. I think in general, that's the way that browsers are optimized. So if we want to make it so that they share tabs, then we need to make it so that, for example, they turn invisible. Or I'm sorry, they turn like blurry or invisible or something, and then you have to click on it to like reactivate it, and then the other one turns invisible. But I mean, that would be kind of bad because you would like to be able to see the stuff that the web card is pointing to. So I think that maybe this is fine. I guess the follow up question is, like, you can have a browser with two different tabs on it visible at the same time. It's just running in two different windows. So how does that work? I guess is the real question. Like, you can have a browser that has a video running in one window and then be also surfing the net in a window on another monitor, for example, and the browser doesn't slow down while you're surfing the net. So are those two browser instances, or is that something else? So let's go ahead and take a quick look here. Also, we can close Blender. So let me take a look at system monitor here. All right, so according to this, I have Firefox, and it's just one, and a lot of isolated web contexts. So if I add a tab and then create a new thing, we go to switch to, for example, there's not two Firefox instances. Web extensions, web content. Okay. Let's try this again with Chrome. I want to see. Okay, so the number of processes does not change. So that means that it's not like spawning another browser to make this happen. Like when you move a tab to another window, it doesn't turn it into another browser. So how do I imitate that design where they can be basically wholly unique? Oops. Let's see. Let's see. Okay. What we're gonna do, let's do some tests real quick. So we choose Chrome. All right, so we don't have a lot of instances here. Let's do, it doesn't matter. We have two tabs open. This. We have a total of, we'll say, okay, we have 20 processes. All right. Now if we do this, okay, we still only have 20 processes. All right, well, I thought it was opening like a new browser each time. If it's only opening one per tab, then that's fine, I guess. Oh, isn't still running, is it? Hmm. Okay. I wonder if there's any way I could make this run faster. I mean, fundamentally, it's taking screenshots. Is there a way I could speed this up? Getting sleep. Yeah, that's not really. Let's speeding things up. Let's see. Oh no, wait. I guess it wouldn't. Excuse me. It wouldn't get faster. It's there we go. As fast as possible. Like it would be cool if there was a way to access the part of memory that the browser is rendering to. Like I feel like that should be a thing I can do, but I'm not sure. Let me get some music, by the way. Also, this isn't going to be a super long stream, but that's okay. That's a password. Processing of an input before frame has been committed, used by headless deterministic mode. Protocol. All right. Let me take a look at my process. I didn't realize how slow this was. Good night. This is like the only way to do this, and have it be like actually responsive. Yeah. Whoops. I need to close everything like that. All right, let's see. So we're capturing the screenshot to a byte buffer, and then we're writing the byte buffer out. I wonder, I guess we can do this through a Go routine, huh? Let's see. We could relegate this to a Go routine to like speed it up. Three milliseconds, 5 milliseconds, 4 milliseconds. Dang, we're spending kind of a lot of time. Not even uploading the data to the GPU, but just transforming it. RGB decoded.at decoded is an image.image decoded. Decode it. So we check the header, parse the chunk, parsing the chunk. Bit. Okay, Big Indian, reset it, CRC check. I'm saying this like I know what I'm talking about. Okay, so we're setting or returning. Okay, otherwise we ignore the first chunk. Well, I guess we can't optimize this at all. For this to be taking 20 milliseconds is already crazy time. So yeah, we might be able to spin up Go routines to do this for us, to do this. Let's give it a shot. So the idea here is pretty straightforward. We're going to take out the use of the label here because we want to make this a Go routine. So we'll say broke out false. So you break, you're breaking out this for loop and you break out of that for loop. Alright. So yeah. Let's just make sure it works currently. Alright, so yeah, 3 to 4 milliseconds. So this might be a prime situation to Go routine because we should already have the data already done. We just need to basically do something about this. And are we still okay? I'm gonna probably say, well, do this. Let's see. So yeah, so what we want to do here is something like this. We want to basically do that loop. Well, do we even need to do the loop? Can we... Hold on. So we could probably turn this into an STL image surface. So we can create a pointer to existing pixel data. So can we also upload it to the graphics card? Raw image is a byte slice. We have to decode it because it's a screenshot, right? Decode is an image. Well, yeah, can we just, rather than decoding it as an image, can we just use the image buffer directly? Is this not just a piece of this? In reverse format? I feel like that might be, I might be like big braining right now. Hold on. Let's see. Can we just... Can we just... Image buffer is a byte slice. Can we just read from a piece of the byte slice? What's the PNG? Oh, doesn't matter. Well, it shouldn't matter because the format, it's a screenshot from Chrome, so the format should always be the same. There's only one image type we're dealing with, only one PNG thing. So PNG format, we read the PNG format directly. Okay. A PNG file starts with an 8-byte signature. After the header comes a series of chunks, each of which convey certain information about the image. Chunks declare themselves as critical or ancillary, and a program encountering an ancillary chunk that it does not understand can safely ignore it. Okay. Length, chunk type, and name, chunk data, CRC. We don't care about the CRC. We don't care about the, well, IHDR is this information. We don't care about this information that much. Let's see. PLTE is a palette. IDAT contains the image, which may be split among multiple IDAT chunks. Slightly increases the file size. Stream matter. Compression. Oh, the output stream of the compression. But there shouldn't be any out compression. It's a PNG now. So I'm wondering if basically I can read the data directly. So let's try this. Let's try this. What we're gonna do, we're going to print decoded.at 0, 0, 1, and 2. So the first three, like this. I guess we can do it like this. Basically, I want to see if I can read the data using the decoded things like this, okay. And then I want to also see if we can read it manually, like tab.image buffer. It said the first byte is 8 bytes. It says the PNG file starts with the 8-byte signature, so let's assume that the 8 bytes 0 through 7, so 8 through 8, 9, 10. Should this be 1 pixel? 0, 0. Okay, let's just grab the first grid. Let's see what we get. Let's see, so it's supposed to be 17, 17, 17. So can we find that sequence somewhere? Only here. chunks. So the first chunk could be IHDR, which would be basically the data. I mean, like, I guess I could make a... Well, because I don't want to have to decode the data if it's already in the format I need. I really want to just grab... Let's see. Maybe I can grab Golang PNG chunk reader. It says it's a pure PNG chunk reader. This might be good. Well, it'd be cool if I didn't have to decode it. Or what if image... implemented bytes reader or something? Like you could read... Let's see. Decode makes an image.image, which just has color model bounds and at. Opaque. Okay. Let's see. Well, how much time is spent decoding it? Well, I guess let's see how much time is spent decoding it. Times 1.5 milliseconds. So we want to not do that if we can help it. Does it? I'm sure it scales up with the size of the thing too. Yes. Okay, so we want to not do that if we can. Okay. So I mean, we could. There should be. So yeah, we want to avoid decoding if we can. Okay, so we should be able to read the bytes because they're already uncompressed, as far as I know. So if they're uncompressed, we should be able to read them directly. The question, I guess, really is, do we want to have to use a library for this or not? And I don't really want to, because I already know I'm just interested in the data. I'm not interested in any other elements of the PNG file. And it should not change. The format shouldn't change. Okay. Well, it still might be compressed. I guess it's possible, right? Like all of these zeros could be some other data. Let's try this. So 17 is only... So there, it must be compressed. Okay. So each byte here does not turn into, or each image, each pixel here does not turn into a byte here. That's not ideal. All right, what if there was a faster library to decode PNG files? Why it's so slow. Well, I don't think I'm gonna find maybe a library that does what I want. So, do I have to decode it to a PNG manually? It's already in a PNG format. Well, wait, can I just make it into a... When we parse it, yeah, can I just make it into a... Let's see, a texture. So we can create a texture of a certain width and height, or we can create it from a surface. It might be faster. Well, if we already, well, don't we already have a surface? Okay, here we go. So we pass it to the raw image. Let's see. Wait, update can take NV or YUV. Y plane Y pitch U plane U pitch V plane V pitch. I wonder if the YUV is a file format? So we are updating with a pointer to image. Can we update with a pointer? Can we avoid doing something? Let's start from here. So we're taking an image, a screenshot, we're putting it into an image buffer. It is a byte slice. It is a byte slice. Can we avoid decoding it? I don't think so. I think that there's some compression or some compression that's always active even if there's no compression with PNG. Because it's like, oh, there's multiple zeros? Okay, well then I don't need to send, a million zeros for a big image. I can just send 1 0 and then like the number of times it appears. Okay, so that's that. So I do need to decode it, I think. If we do need to decode it, is there any way to treat an image as a byte slice? Oh, you can encode it as a writer. Okay. All right, so let's time this so we can see if we're doing it better or not. This. Decode is taking some milliseconds. So now I want to see if we can do an automatic decode, which would be basically, if we already have the data as a decoded image, then we should be able to use PNG encode, and then use a writer. We can bytes new buffer. And then use our decoded image. So we want to encode it as hold on, I gotta okay, here I am. So, let's see. So yeah, I think we could encode it to a byte slice of the appropriate length, right? And then we should be able to update it using an unset pointer to the byte slice directly. That would be the raw image. Like that. So let's see how this works. Wrong number 8. All right, let's see. Auto decode is 7, 10, 6. Okay, so it is a little slower. Auto decode is 9 milliseconds. Manual is 4, so it's actually faster to just do it this way. I guess because we kind of already don't need any of the other stuff, I guess. But yeah, auto is slower. All right, so I think the only way I can see to do this would be to use go routines to basically like brute force our way, which is not ideal necessarily, but sometimes that's just what you gotta do, right? So what I'm gonna do is just do this as naively as possible, and we'll see how this works. So I'm gonna do this in 2 stages, so we can, or do this twice, so we can kind of see, compare and contrast like this. There we go. Oh, I think. Okay, so they're basically the same. The go routine one is slightly slower, faster rather, already, just because probably data locality, all that stuff. Again, talking like I know what I'm talking about. So we're gonna make decode a function that does this, and we'll say y start is an int. Y start, like that. And then we just say decode 0. Okay. Or I guess, yeah, y start, y int. So these two are the same. Actually, I guess we could just do return here. Also, I guess I should be here. This, and then I should be y start times tab.raw image. Is it the length of the image? It's the pitch, right? The idea is if I is greater than the length of tab. So it should be y start, right? So x times size of the image horizontally? Do I ever know that? Image buffer doesn't have that decoded, I guess. Okay. All right, so I think that should generally do it. All right, so all right, about the same amount of time. So let's say we only wanted to do the first quarter vertically. Takes about a quarter of the amount of time. 0, I is less than 4, I is less. I times image. Alright. So that's the idea. So you notice how this is fast is because we're not waiting for the go routines to finish. So we'll make a wait structure. It's called, is it sync that wait? No. Oh yeah, sync that wait group. Okay, so we'll see. We got a first time chatter, first time banned. First time chatter, long time blocked. All right, okay. So let's see. So if we use a wait group, we'll wait for it to be done. That can't possibly be the case. It can't take that little amount of time. Oh, I see. So we want to probably add one for each time we do that. Okay. It's probably finishing before the go routine spins up. That's what's going on. So let's see how that goes. Okay, we reduced it significantly, possibly. Is this something that requires a lock? Okay. Okay. So it is faster. So I'm gonna take out this first. Delete that. It freezes because there's probably a deadlock. I'm guessing the wait group gets obliterated. Why would the wait group be obliterated? Yeah. Maybe the wait group is obliterated. Because if we resize the browser, so I guess we should lock. Actually, let's resize. Update buffer size. It locks already. But if we are already locking the pause mutex, we lock and then we defer and unlock. That means that if this is locked and we're waiting for this to happen, then it can't update the buffer size. So then how is it possible that this is freezing? Let's see. What could be the problem here? I feel like I'm like on the cusp with this being a lot faster, which is fantastic because I did not think it could be faster. Okay, so we're spawning, we're waiting, and then we're decoding, and that's the total amount of time. If we change the size, we spawn and wait. It never waits because the go routines die. Oh, because they return. I see. So then we need to defer done. Like that. There we go. Okay. So it is working. So it is faster. We don't need these anymore. Do we want to time this? Maybe we do want to time it because, well, no, we don't. I don't think we need to time it. Well, you know, actually, let's go back. I want to see what the ideal amount of chunks is. Ideal amount of go routines is. Okay, so this is 4. Let's say we spawned 16 go routines instead. Better. It's almost sub 1 millisecond. That's pretty good. So I guess it depends on the number of threads you have in your processor. So more threads equals more go routines active at any given time, right? So yeah, a certain amount, it just doesn't matter anymore. Let's see, we can get the thread count, right? Well, okay. Sorry with 4. Okay. All right, so this should be basically choosing the maximum number of CPU threads to perform this with. Alright, so I should be able to say like, oh, I want like 20 FPS, and it should basically work. And it does, okay. Give me a bigger part size. It's only 3 milliseconds, but it's slow. So that's probably because it's taking the time to upload it to the GPU, huh? And we can't do that here, can we? Doesn't look like it. Are we getting an error, or is this just silently failing? No error. No GPU texture. Fairly slow. Wait. The pixel data must be in the pixel format of the texture, which can be queried. It's a fairly slow function intended for use with static textures that do not change often. If the texture is intended to be updated often, it is preferred to create the texture as streaming and use the locking functions referenced below. Really? Lock a portion of the texture for write-only pixel access. Oh. Really? Okay. So that changes things. They are streaming. Okay, it is set to be streaming, but we need to lock the texture rather than updating it manually here. We should be using lock, like that, and then unlock, right? This should return a byte slice data. Okay, so then that would be better than updating it manually. So let's try that. This isn't going to work, by the way. I already know this won't work. I'm just trying to see. Okay, so here's our data. Oh. Okay. So here's our data. It is a byte slice that is massive. I'm not sure why, actually, why it's so big. Okay, give me the first, like, 10 values and the length. I imagine that's what it's supposed to be, right? $18.20. Okay, well, what's the length of the data? Is this actually... the length of the data, or is this something else? Is data not... yeah. Data is this right here. Oh, I see it. This is... oops. Hold up, everything's like slow. Give me a second. Let me restart this. Let's see. Length data. Oh, length. Are these not the same? I just want to make sure I understand. Because I'm thinking that data might be like the backing buffer or something. Like it's not going to be the same size. It is not. It is much bigger than the actual length. Okay, so then we only need to provide first 1820 values. So we should be able to just do data maybe just copy. Yeah, I think copy is destination, right? Can I get a autocomplete for this? Anybody? Dest is going to be data lane, and the source is going to be b.raw image, which should be the same size. Let's give it a shot. Oh, wait. Yeah, it should be the same size, no? Let's see if it is. Nope. Crash or anything. Minimum of length source and length disk. Okay. Okay, and then unlock is supposed to upload the changes to video memory if needed. What do you mean if needed? Only be called on the main thread. Okay, so I can't call this from another thread. All right. Okay, we're locking. We don't need any specific. I feel like this should work, but maybe it's not for some reason. Let's see. How big is raw image? Raw image is much bigger. Oh, these are the same. So why is length? Oh, maybe that's the number of pixels. It's the pitch. It's the length of one row in bytes. Okay. All right. So then we want to just copy the entire thing. Then we don't need length, I think. So this should work. Cool. All right, so now it should be faster, right? It should be a lot faster, I believe. Ooh, that feels fast. Oh, that feels super smooth. Oh, that's right, because this is as fast as, yeah, it's 1 FPS until you like click on it. Okay, so then yeah, it's gonna feel smooth. All right, let's go back to 512. That's faster. That's significantly faster. That's good. It's not perfect, but it's a lot better than it used to be. I'd say that's probably good enough to ship. right. Not perfect, but definitely pretty dang good. That's pretty fast. Just a tiny little screen. But there's a bottom area that's not being copied. Let's see, is there anything I can do about that? Definitely could be. And that, well, that's not part of, is that part of Steam? No. Okay. Alright, so there's definitely something at the bottom. What could that be the cause? What could be causing that? Oh, yeah. It's probably caused by this code here, where I get I'm basically going by, like, I'm cutting it up into pieces, but it's entirely possible. Well, I guess here's what I guess I can well, no, hold on. Y start and Y is less than Y end, and we're cutting it up into fourths. Oh, well, oh no, we're cutting it up into 16ths. Because, or whatever the number is. I'm thinking that it could be... I'm thinking that it could be, it's got to do with basically this code here, I think. I is less than chunk size. Let's see. I times image height divided by chunk size. So if it's 1, it starts at 0 and it goes to the height divided by chunk size. I'm thinking that it may not be evenly divisible. I think that that's really the problem, right? Like if you have a chunk size of 12, or we'll say a chunk size of 3, and your height is image height, the screenshot height is like 307, the last bit is not going to get done. So I think what we want to do is something like this. But then we could probably do this like that, just to make sure we decode it all. Well, that probably would be enough. We can try this. Let's give this a shot. That looks better, I think. This is kind of sick. This is kind of sick. This is kind of sick. It would be cool if I could, or it might be better if I were to resize the screenshot. Like if the screenshot was 50% of the size, I could decode 50% of the data, but the layout wouldn't change. That's really the most important thing. Like when you change the size of the web card, the layout changes because obviously you're changing the size of the browser. But if we could kind of like make sure it's always the same size and then it's just the screenshot that changes the size, then we could control how much data we are transforming, and that would allow us to speed it up more dramatically at just a loss of clarity. So the screenshot would appear blurrier, but it would also run faster. So maybe we could do that. Maybe we can like what we want to do is basically change the size of the screenshot. Or we want to size down the screenshot. We want to scale it. Let me see, can we scale? I kind of feel like I remember that, but let me see. Full screenshot. Okay, this page says, let me zoom in. Chrome DP full screenshot overrides the device's emulation settings. Use device.reset to reset the emulation and viewport settings. So can I change the viewport to be a different size than the device, I guess is the question. So let's go ahead and go to device. Yeah. So here we're setting the width and height, we're setting the scale. What if we set the scale to be twice its original size? It does not matter. No, wait. Doesn't the text look kind of crispy? Yeah, no, that wasn't like that on 128. This wasn't visible at all on 128, wasn't it? Like it wasn't. Oh no, wait. Okay, the width and height is times device.scale. What if it wasn't though? What if we could change the scale independently of the device width and height? That makes sense, I guess. Why it doesn't look correct. The width and height, the buffer width and height is into this. The width and height is if the scale. What does the scale, device viewport scale factor? What other options are there? That's all of them. All right. And we're setting the user agent here. Okay. Let me think. Hold on. So we set the width and height of the device, and then we have the scale. What if we could change the scale independent? What if we could change the scale independent? What if we could change the scale independent? If we could change the scale independent, that would allow us to make smaller images while maintaining legibility. Like, because you probably don't need 1 pixel to be 1 pixel large. You could use 2 pixels to be 1 pixel large. Like, we could do a scale of 0.5. But that won't work because the buffer size isn't the same. But we don't need the buffer. We want the buffer size to stay the same. How can we do this? I think I'm like knocking on the door of making this actually like really good. It's just a matter of how do I do this? How do I change the buffer size? When we take the screenshot, it's going to be the size of. It's when we decode it. What's the decoded? Let's see. The width and height is 228 by 128. So the screenshot is half size. Okay. Then we want to basically put it into an image buffer of the correct size, which means we probably want to do width and height. Okay, so we could do something like this. Float 32. I think we could do something like this. 32 times scale. Float 64. All right, let's try that. Then it should be able to. No, huh? Scale. Shrink it down. Image buffer. We can still use image buffer. We do. That is where I see where it is. Okay, so we're decoding it. So the decoded image is half size. We are decoding less data, which is good. We're able to see it. That means that it's being uploaded. Oh, well then, hold on. Yeah, this is just what I did before with multiplying the size by the scale. So what if we just change the scale, I guess is the question. So this is what it looks like normally. So what if we just make the scale half? Well, but see, the issue is that the width and height of the texture changes. We don't want the width and height of the texture to change. Do you ever actually use buffer height? Like, kind of? A little? I feel like I'm like right on the cusp of this, dude. This shearing indicates that we're not doing what we think we should be doing. Let's see. Well, the scale shouldn't change the size of the image. Oh, it does change the size of the image, huh? It changes the size when the screenshot is taken. Yeah, okay. Ideally, we wouldn't have the scale change. We can't change the scale, huh? I'm like right on the cusp of this, dude. I'm like super close. Force device scale vector. Okay. All right. What if we did this through a flag? There's no flag for this according to Chrome Launcher. There's no flag for scale vector. Let's see. Let's see. So this guy was getting screenshots of a different size. Half width and half height. Should have been like that. Let's see. Look at the emulation domain, specifically the emulation.set device metrics override. Oh, actually, what else was there? Window set device pixel ratio. Let's see. Where does window get? Device. Oh, that's, I guess, JavaScript. I see it directly in HomeDB. Okay, so let's try this in order. So we'll try this emulation. Device metrics override. Overrides the value of device screen dimensions. do with enable do with do context. So B dot context. Yes, that's what we're trying. All right. Let's see. Let's see if this works. Also, I guess no, it probably wouldn't, right? Because we're setting the device info. And then we actually use. Oh, we do it there. By 780 by 493. Let's see. Okay, that works. But I can't do like this and make everything bigger while keeping the image size the same. That's what I'm trying to do. Yeah, no, I can't. It makes the image bigger. If I can keep the image size the same and just make the UI bigger, that would be ideal. Is there any way I can do that is the question. This guy said he used JavaScript, huh? Changing the device pixel ratio. The device pixel ratio of window interface returns the ratio of the resolution in physical pixels to the resolution in CSS pixels for the current display device. Okay. So I mean, I guess zooming is pretty much the same thing, right? Can I just zoom? Let's see. Zooming the pacing. When zoomed, so okay. So the device pixel ratio increases. Okay, so let's try this. Maybe we can do this. Maybe we leave everything the same. And we can just do B dot do I guess this is what I'm looking for. And just replace this with to make everything bigger while keeping the texture size the same. It did not work. Let's see. Unless I have to do it like live? Like, do I have to do it after it loads? No, that shouldn't be the case, right? Also, I guess I need this. Well, I don't think I need that, but sure. Oh, also, yeah, this would be window. Window dot. Is it capital? No. What if I set it? All right, let's try something. It might be that I'm just not doing this right. Let's see if I can do this. Window dot. So I set the device pixel ratio, but it's not changing. Not actually zooming in and out. Let's see. JavaScript zoom. Document body style zoom. Let's see. Alright, let's see. So this says I could try document body style zoom. Let's see. Okay, so that does work. But this does not track if I go to a different website, right? But I can do that. Okay, so what if we do that? What if we do that? What if we say document? Yeah, document body style zoom. What if we increase the zoom or decrease it for that matter, either one? All right, so this is still the same size image, but now the text is just bigger. Cool, so that means that we could also do this, make the text smaller while maintaining the image size. Which is good because now there's just less data being transferred, which means we can speed this up and make it smoother. Yes. Okay, well, if I can make it like that, can I also make it so that the textures are crisper? that logo is funny, dude. That logo is like it just feels like a it's more than this particular duck bargained for. He's like he's been flattened. Okay, so I can say like, okay, I want it to be smaller. I can go to Steam Deck, Steam or Steam Deck, whatever, and then now it's crispy and it's crunchy, which may not be advised, but it's still cool to do. What's our frames looking like? I don't know if that's 60 FPS, but that's smooth, dude. All right, dude. This is a lot better than it could be. All right, so there's a couple things. We don't need to make it not blurry. I think it's fine for it to be blurry, but we can make the zoom customizable. I'm guessing, let's see, cannot read properties of null, reading style, and anonymous. Okay, so yeah. So it only needs to do this when it goes to a new website. We can control the zoom level of the web cards. Yeah, so what we can do, we can go to do I have something that tracks when a card tab goes to a new location? Listen. Yeah, here we go. That is this, right? Do I not use this? I do. Okay, so when we have a listen target, we can do this. Browser do. Let's see. Crazy. This is crazy that this works. So then we can just do that. We can just basically make different zooms, and you can, you know, work with it as you'd like. Like a zoom of maybe like 75% would be good. Smooth as this. It's like it's hitting like 20 FPS. That's not like fantastic, but that's the best I can probably realistically get it to be. Yeah, I think 75% is probably good for a base, because that allows you to kind of see a little bit more than you normally would with a card of whatever size it is, without losing clarity in text at default size. Okay. All right, that's really good. I'm happy, really happy with this. To speed this up at all was great. To be able to see more reliably, that's really good. Rather than needing to rely on a larger device size, you can instead. Excuse me. You can instead. Oh, I never figured that out. That's right. That's right. There's that issue where videos just like mysteriously died. Oh no, wait. Yeah. Never mind. I might have figured that out. No, never mind. Yeah, there's something going on. Something went wrong. So that's something else I gotta figure out, dude. But I mean, the fact that this works at all is kind of crazy. So I think a default zoom of 75% is probably fine. And then we can maybe offer like 50%, 100%, 125%, something like that. Or maybe just go up. Yeah. Something like that. I guess it would be good to set that as a setting in your, as a global setting. So we'll add that. Maybe I don't want to do this as like steps. Maybe I want to do this as like a slider or something. Maybe I want to do this. A slider. How would that work? Well, it would be a slider. That's how it would work. Wait, hold on. Do I have an ability to roll the settings back to default? I don't think I do. Yeah, I don't. Do I even have a... I don't, do I? I don't have any... Oh, I have this. Okay. Okay, Didn't I see that it was? Okay, no. Okay, all right. All right, so I should be able to do this. Let me see. Where do I use scroll? Ah, okay. Scroll bars. For sound contents, for web contents. Okay, so then we probably don't want to do that. So then maybe. Okay. All right, it's working. So all right, let's see. This is supposed to be a short stream. I got caught up in making too much progress. Oh, it's X1. Brother. There we go. Okay, this is what I'm looking for. We can do 58 maybe. Oh, maybe I can just do this. There we go. Beautiful. Okay. We're cooking. Before you know it, we're cooking. I'm cooking. Okay, so that's good. Cool. How do we, let's see, format this? What's the trick? Oh, I guess we can just do. Oh, it's probably like that. Yeah. It's 0.0f maybe. Cool. So then, yeah, the web card zoom level could be like that. So you have a range of options. Let's see, so the max minus the minimum, so it's 1, let's say it's 2 minus 1, so it's 1 times the target value, so it goes from 1 to 2, 1 plus 1, right, and then we say, right, okay. Cool. So the reason why I did that is so that we could do this. go from 0.5 to 1. Oh, I see. No, that goes the wrong way. Value min is 0.5 plus max minus min 0.5 times this. Oh, max minus min. Yeah. 1 minus 0.5 is 0.5 times the target value. Minimum is 0.5 plus max minus minimum 0.5 times target value, ranging from 0 to 0.5. Okay, let's see. Multiply it by 100. Multiply by 100. Multiply by 100. Does that make sense? It should. Does it range from 50 to 0? Value min 0.5 plus max minus min 0.5, 1 minus 0.5, 0.5 times the target value. It goes from 0 to 1. So at 0 is 0.5, and at 1 it's 1, right? Maybe this is what it needs to do. Maybe? I don't feel like it is, but let's see. Oops. Here we go. Okay, yeah, that's right. Now this is wrong. Let's see, group max buttons per row. Oh, I see. 32 times. Cool. All right. So then we just gotta go over here to browser and set the zoom level. Yeah. Precision. Precision is, I guess 1 is fine, right? Bit size 64 is fine. Because this was, it was 75%. Oh, it's 0.5. Okay, so then we can just do that and precision. Okay, let's try that. Interface is string not float 32 61. That's right. Let's see. Hold up. I know it said this. Huh? Yeah, I never did. Okay, I pronounced that. That, whatever that was. Oh, drop it. Still didn't like that. Close. Oh, there it is. Okay, web cards and super simple. So why then? Oh, it is. Okay. Is it just not reloading? No, it's not. It's not being set. Yeah. Why isn't it being set? Oh, yeah, right. Oh, I see. Okay. Right. All right, that should do it. That should do it. All right, I think that's pretty good for now. I'm not sure if I want the cards to refresh when you adjust the zoom. That makes sense, but at the same time, that would lose your spot on the card on the page. I don't know. I gotta see on that one. But yeah, for now, this is going to be it. I'm going to call it here. It's been very enjoyable. Thank you very much for watching. It's been fun, and it's been cool making stuff. And this is shaping up, man. It's looking and feeling good to use, and it's more efficient and stuff. It's good. Yeah, so thank you very much for watching. I've been SolarLoon. It's been real. I'll catch you guys on the flip side next time. That's going to be Friday at 5 p.m. PST. All right. Thanks for watching. See ya.